Hello friends, this is Mike from Wright, and this is the explanations video for SAT 2's Math No Calculator section, question number 12. So it starts off by giving us this equation up top, r equals f divided by n plus f, and then it gives us an English language explanation of what that equation means. A website uses the formula above to calculate a seller's rating, r, based on the number of favorable reviews, f, and unfavorable reviews, n. Which of the following expresses the number of favorable reviews in terms of the other variables? Now it's this in terms of that should get your spidey senses tingling if you've done isolating quantities questions before. But if you haven't, or if you don't remember, basically isolating quantities questions have this same structure where they give you a equation up top, and then they give you what is often a very confusing, what seems like a word problem, a confusing English language explanation of like this detailed thing where it's like, oh my god, there's favorable reviews and unfavorable reviews, and what's the seller's rating and all this stuff. Oftentimes they'll throw in complicated scientific jargon in there, we're calculating the airspeed velocity of an unladen swallow, But then the question that they ask you is a very algebraic question. They're saying, which of the following equations, which of these equations expresses the number of favorable reviews, which is f, in terms of, and this in terms of is the common phrase they almost always use in these isolating quantities questions, in terms of the other variables. Here they're just saying, which of these equations takes f and puts it alone by itself and throws all the other crap in the equation on the other side. So even though this question presents itself to us mostly in English because of this big long paragraph, really at its core, it's an algebra question. It's a question asking us to do algebraic manipulation to take this equation and change it so that instead of r is alone, we're going to do stuff to it to make it so that f is alone. That's what all of these questions, that's what all of these answer choices have in common. They're the kind of answer choices where f is alone and all the other crap is on the other side. So you don't need to understand, and in these isolating quantities questions, you often really ought not to try to understand the English language version of what's going on, because all you need to do is algebraic. All right, so this is another one of those instances of like understand the language you want to be working in, understand your task. If you want more practice on like realizing that that's what you're supposed to do, look at the isolating quantities theory video or do isolating quantities practice in Khan Academy. You'll pick up on the pattern pretty quick. So on to the execution of how you actually get f alone, because that's kind of hard, honestly. So here we're just going to start off by writing the equation over again. So this is just r equals f over n plus f. That's just first step right here. And then the first thing we're going to do, and this is tough. So one of the hard parts is we have two f's, right? It's not like we want to get this f alone because we need to take this f and take this f and make them so that they're the same f somehow. We need to combine these two f's and then get those two f's alone. And it's weird because we have these two f's on this side and we want to get rid of this n, but this n is kind of attached to this f too much. We can't just multiply both sides by n. That wouldn't do it. So in order to, we kind of going to need to go a roundabout way. We do need to get this f off the bottom though. And so the first thing we're going to do, and I would encourage you kind of just to play around with lots of different things. It isn't necessary that you happen upon this way the first try. But here I'm just going to take n plus f, this whole chunk, and bring it to the top of the other side. I'm going to multiply both sides by n plus f so that the n plus f moves as a big chunk over to the other side. And it gets at least the hell off the bottom, right? So now we don't have this crazy fraction with two f's in it. We're going to have a nice everything is on top type expression. That's what's happening here. Here this n plus f got moved over here from the bottom to the top. We're multiplying both sides by n plus f. So we've got r times n plus f, and we've got f over n plus s times n plus f. The n plus f cancels, so we just got f over here. Now we're going to sort of, well, here again, we want this f to be combined with this f, goddammit. But it's not in a position where we can just move it. We can't subtract both sides by f right now because f is kind of caught up in this parenthetical phrase. So we're going to get it the hell out of this parenthetical phrase by distributing this r. And that's what's going on in this step here. We're going to take r, I'm going to multiply it by n, and multiply it by f. So we're going to end up with rn plus rf, right? Now we've got this f in a position where we can move it over to this side and get it on the same side as the f. So hopefully we're going to try to combine these so that there's only one of them. So that's what we're going to do. We're going to subtract both sides by rf, by this chunk. And again, we can't just subtract both sides by f because, again, f is still caught up with this goddamn r. You know, so, but this is okay. We're going to move it over to the other side anyway. And so we're going to end up with, so instead of Rn plus Rf equals f, we're going to subtract both sides by Rf. So we got Rn and then Rf minus Rf. This cancels, so it's just Rn alone. And then equals f minus Rf. All right. So now we finally have something, and then we have both of these f's kind of together. And this is, I would say, the hardest step in this question. It's the step that got me stumped for a little while until I thought of it. And this is, it comes up, I would say, like pretty rarely on the SAT, but it comes up, I've seen it certainly more than once. I've seen it maybe, I would call it like 6 or 8 times total in all of the SAT questions I've seen. And the step is, it's like where they require you to factor a variable out of an expression, do basically the opposite of distribution here. It was basically going from this step to this step. Right here, you could distribute this r to the n and the f, so it's Rn, Rf. Factoring something out is just doing this in reverse, taking this r and pulling it out. So Rn divided by r is just n, and Rf divided by r is just f. So you pull the r out and you say r is times n plus f. That's what we're doing here with this f. We're saying here's an f, and this is minus r times f. So this is like a 1 times f minus r times f. And we can factor the f out. So that's what's happening. And you can kind of, if you're having trouble understanding how this works, imagine the process in reverse. Here, if I showed you that f needs to be multiplied by 1 minus r, and you wanted to distribute that, you would take the f and multiply it by 1, and that's how you would get this f right here. And then you'd take the f and multiply it by that negative r, and you would get minus rf. Factoring out is just our ability to do that process in reverse. We're like de-distributing, undistributing. And this is how, this is the big trick. This allows us to take these two f's that are, f is kind of on its own, and this f is attached to an r, and turn it into this one f right here. This one f that is multiplied by 1 times r. Now, once you've done that big step, and again, that's a pretty hard step, but it's something that, like, if that was the step that caught you, allow that mistake to burn you, and think about it. The next time you're stuck trying to, do something that's almost exactly like this, hopefully you'll think to yourself, maybe I can factor something out. But then once you're here, right, you've got Rn equals f times 1 minus r, and this, we just need to take this chunk out to get f alone, so we're going to divide both sides by that chunk, 1 minus r. So here, this is how we get our final answer. Rn divided by 1 minus r equals f, and that's what's going on right here. All of these other answer choices are just, I don't know. I'm not exactly sure how you would get there, what specific mistakes you would take to get there. I tried to do a bunch of different mistakes, and I wasn't able to find any that easily led you there. But I imagine they're there to make it harder to just guess, because without doing this step, without getting this step, I think it is pretty difficult to guess the right answer straight up. But if you do remember it, that's how you can do this question. It's just really a matter of doing this and understanding that this is an isolating quantities question instead of one that's a super hard word problem that you need to understand deeply. And then, everything else is sort of straightforward algebraic manipulation. All right, that's all for this question. I'll see you in the next one.